Hey everybody, and welcome to another Jamovi tutorial. In this tutorial, we're going to talk about a new additional module available in Jamovi. Additional module because you have to add it if you want it. It's called FlexPlot. Here it is. FlexPlot. It's next to my StatCat if you wanted to take a look at that video. So, in a bunch of my other Jamovi videos, I've been talking about the basic forms of modules and functions that Jamovi can do, but you can go to Add Modules here, this plus sign, and add tons of different packages and modules into Jamovi to use with Jamovi's user interface. Same way, it's the same kind of way that you would do with R, but this one's a little bit more approachable to people who are like, ooh, R, you have this code. So we are going to talk about FlexPlot. We're going to talk about FlexPlot in this one. So here are all of my installed packages. And of course, there are far more, but we're going to do FlexPlot made by Dustin Fife. FlexPlot Suite is a graphically based set of tool for data analysis. FlexPlot allows users to specify a formula, and the software automatically chooses what sort of graphic to present. GlinMod allows linear modeling, and like FlexPlot, chooses an appropriate graphic to present alongside the statistical, and it gets cut off. So we're going to do that. We have a data open. So I'm going to open that in just a second. But before I do, I want to let everyone know that I'm using the current build 1.6.16. And this is, at the time of recording, what appears to be the most updated version for Mac and PCs. And so let's open up some data. Okay, so here we have the Parenthood dataset from the data library that comes pre-installed with Jamovi. And here we have an ID variable. We have the amount of sleep Dan gets per night, Dan apparently being the dad, how much baby sleep is getting per night, and how grumpy Dan is, and then what day it is. So we are going to predict the amount of grumpiness, although I'm going to change that to a continuous variable. To make this easier. So we're going to change the grumpiness, we're going to plot the grumpiness of Dan. This is going to be my dependent variable based on how much sleep Dan gets and how much sleep his baby gets. So let's go ahead and go into FlexPlot. It looks like it's a bunch of different kinds of plots in that kind of looks like a creature, but I think it's just a bunch of different plots. And we're going to do the general linear model for this. And so our outcome variable, like I said, is going to be the amount of grumpiness in Dan. And we are going to use a predictor, these two predictors. I'm sure we could put in day, but I don't want it to get too weird. So we're going to put those in our predictor variable. And just by doing that, what's checked by default is analysis graphs. And that's what we get here. These three things. So these are plotting the amount of Dan's sleep on the x-axis and the amount of Dan grump, and plotting three various cases of how much baby sleep is. So three, we'll call them, three plots. I'm not entirely sure, but this is 3.2 to 6.9, 6.9 to 9.1, and 9.1 to 12.1. And you can see the changing graph. And now there are a number of things that we can look at in this analysis, right? So we have our plots. That's on by default. We have estimates and effect sizes. That's down here, okay? And so we have our estimate of basically our slopes, intercept, and then slope of Dan sleep and baby sleep, because those are two predictor variables, how much sleep each person gets, and the 95% confidence interval with that. Now, we get our R-squared and our semi-partial R-squared estimates for the model itself. It's a pretty decent model. And then our R-squared estimates for that. For some reason, the difference between factor levels of categorical predictor, because we don't have a categorical predictor, and so that's not going to be in here. The estimates of effects sizes, I guess the 95% confidence interval is the effect size. Okay. We can also grab diagnostics. We'll see what diagnostics. This gives us our residuals. So our histogram of residuals, they look normal. That's good. Relatively normal. And then this is a fitted line residual dependence plot. I think that's supposed to say T there. And then we have our SL plot. And so we have our fitted versus the absolute value of residuals. And so we have a decent set here. And if we have a decent model here. And if we go down to the model estimate, 0.816 is a pretty good R-squared. And then we can change the fitted line to a line. Watch what happens. They get straight. Look at those. So you would mostly see the regression lines set up like this. Maybe you wouldn't see it in three different graphs for the amount of baby sleep, but you would see straight lines. But you can do low S regression, and logistic would not work here because this isn't a dichotomous outcome. Right, so we go back to regression here, so we get solid lines, and you can see that this turned into a solid line, solid horizontal line. Center spread for dots and plots, we can change. So by default, it is the median with the quartiles, but if we change this to mean and standard error, it changes changes the way this kind of looks. It doesn't look that crazy, to be honest with you. But the standard errors now are represented by this gray bar, or I guess the gray funneling, if you will. And then the mean and standard deviation then changes the analysis plot a little bit, not too much, but again, instead of standard error, it's now standard deviation in the funneling there. I would probably do mean and standard error if this were me. And there we go. There's the kinds of plot it is. Now, there is another function, and we'll see if we can do it with our current set of data. So you can also do so that was a particular, it was just regression based, right? So it was just FlexPlot, general linear model. That's all things that come out of regression. And then there's this other FlexPlot, right? And so we can do something like Dan Grump, so his grumpiness levels. So by the way, his grumpiness levels increase when, his baby doesn't sleep, and so therefore he doesn't sleep. So that's what it comes down to. We're going to put baby and Dan sleep in the predictor, and let's see what happens with paneling by day. There we go. Paneling is done. So instead of paneling by baby sleep in this case, I can both include, so what happens here is baby sleep gets binned into these 3 colors. So it gets binned into those 3 colors, and let's make sure that we are changing this to regression. So we're gonna have 3 lines for each of the 3 panels. So day 1 through 34, 34 through 67, and 67 through 100. This one was fairly easy to set up as 3 different bins because these are approximately equal amounts of days, 34 days, and 33 days. So these are approximately equal, and you can see where each of these lines end up lining up. And the dashed black line is the overall regression on this, right? And we can also suppress that fitted line. So the bins are only represented by dots here, and you end up with a connecting the dots kind of pattern going on. I don't know if I wouldn't want to do that. But you can change the plots as well, right? Because this is just giving you the plot. It's not giving you any of the other analysis information. We can see what happens with the added variable plot. So Dan sleep by Dan grumpy given the day and baby sleep. I believe that's how you read that. We could also do a difference plot. If it, I guess you do one or the other or none. And we can do point options, and we can change the jiggering on here, or jittering, in X and in Y, so you can see these a little bit more. You can change how many dots, percent of dots to display, and then how much transparency each of the dots have. So 100% transparency does not mean what you think it means. Transparency 100% is actually opaque, because if I change this to 0, I think they should change that to opaqueness of dots. Will make sense with the scale, because if I put in 0 here, they're fully transparent. Dots don't appear on the graph at all. By default, they're set at 50. And so they're a little faint here and there. And then we can change the paneling here if we want by either taking away or adding that ghost line. That's the black dotted line that you see here. That is sort of a sum of that. But you can also change the amount of bins. So we could have 10 bins. Okay, 2 and 6. All right, fine, 6 bins. Invalid labels. Labels should be 1 or 3. Okay, fine. 3 bins. Fine. Can it do 4 bins? Yes, it can. So this gets quantiled into 4 different days. So day 72, this is some wild confidence bands. Wild confidence bands. But there you go. That's how you do FlexPlot. And it's just an interesting little thing. I myself like ggplot, and if that were to be added to Jamovi, that just blows Jamovi out of the water. I don't think I'd ever use R again if ggplot made it into a module here. I haven't looked, so if that's the case, if it's already here, then wonderful. But if the devs of the ggplot and the tiny universe, tiny R universe, and make it into Jamovi, Jamovi is a powerhouse there. But just different ways to plot stuff than the traditional ways to plot things over here, right? So that's how you do FlexPlot in Jamovi. Let me know how you use FlexPlot in Jamovi. Leave your comments, suggestions, and feedback down below. If you like this content, consider leaving a like. If you want to see more, consider subscribing for more of this Jamovi content. There are so many modules that are coming down the pike here. Thanks for watching.